you guys, 479, you have to do 478 first. Or you have to know I'm going to use what we did in 478 to answer this one. So the setup was showing that when you have a triangle that's been cut by an angle bisector, that the proportional sides exist, and they absolutely do. So then what we built is this monstrous, here it is from start to finish, this monstrous flow proof that is trying to put together the sequence of everything that's taking place so that finally we get to say how the sides in the triangles actually do form proportions. So the goal now from the flow proof is to fill in the blanks on this 2-column proof. I've got this work on the side, which is what that was from that video, and now I'm going to write it into the 2-column proof. The statements are the first things, the reasons are what go below them. So the first one is the given. Always lead off with the given. AD bisects angle BAC. Done. The next thing is this idea of the construction. So we have parallel lines CE to AB. That's done by adding the auxiliary line. So that's what is going to be my next statement. And like we've done off of our online math homework, when you do a flow proof and then you turn it into a 2-column proof, you work top down. Okay, next up, so we have the word bisect being used, and in the flow proof we had this, what that means, angle bisector statements. So that'll be angle BAD congruent to angle CAD. With an A in the middle, oh my gosh, done. Okay, now next up we have, well they have BAE, I have BAD, that's the same thing, but this is because of alternate interior angles, and so I'm going to slide this over. Alternate interior angles, and it's a theorem. Okay, so then that one's done. Now I wrote this one in red on the last video because if you know that we have 2 base angles of a triangle and they are congruent, you have an isosceles triangle. But they skip ahead to this one. In fact, they skip ahead to the, oh, not yet. I'm sorry, I'm getting ahead of myself. I got to follow my arrows. I got to get to this one before I get to this. This one can't be said or written down until that one's first. So angle CAD is congruent to angle CEA. And the explanation was BAD was in step 3 and step 4. So then replace it with what it equals, CAD and CEA. That'll be step 5 because of transitive property. Now I can cross that one out. Since those angles are equal, they're in one triangle. The triangle is isosceles, but we know that, so we're going to use that to say that AC is congruent to CE. That one's done. Definition of congruent segments. That's this, follow it down to this box. So then AC is equal to CE by the definition of congruent segments. Okay, keeping things back in order here and working on my flow proof. It's flowing down from top to bottom. I guess this should probably be next. And I noticed that step 8 has the reason, alternate interior angle theorem. So yes, this is next. Angle BCE equals, congruent angle ABC. Now, if these are the same, so we have an angle pair and we have another angle pair, this is the angle that make triangle DAB similar to triangle DEC. Angle similarity theorem. Okay, now AB, since the triangles are similar, cross that out, cross that out. Since the triangles are similar, then they have corresponding sides that are in proportion. So therefore, in step 10, these sides are the corresponding sides. Corresponding sides of similar triangles are proportional. Okay, so then that takes care of that box. And then this last one at the end of the proof, trying to get it on camera, this last one at the end of the proof is the thing we were supposed to prove way back at the beginning. So this one right up here, way up here. So therefore, we get to say how all of this feeds together. Somewhere AC way back up in the beginning was being replaced replacing EC/CE with AC, this is substitution. And there you have it, the entire two-column proof that shows when you have an angle bisector in a triangle, the sides on that triangle will be proportional to the sides that are split when the angle bisector touches the other side of the triangle. This is specifically known, finalize it out, highlighter time, the angle bisector proportional side theorem. And more than anything, it's probably up for an example. So on the side here, example, triangle, and then maybe some highlighter. So I've got these two sides making a fraction, and I've got these two sides making a fraction. We'll call this side A, side B, equal to side C, side D. There is our proportion. Get this off of my face. Thank you so much for watching this video. Appreciate it. That should conclude activity 2, where we talk about the angle bisector proportional side theorem. You probably should go practice it. And that's what we're going to do in activity 3. We're going to practice how we apply it into some real-world problem solving processes. So thanks for watching. Stick around. Page 479 page 480 episode is next. See you in the next episode. Happy mathing!